Greetings. Welcome to the broadcast. What we're going to talk about today is technology forecasting. This is a super technique. It really is part of the intersection where business thinking meets technological thinking. So it's a very, very important juncture. It is also, I think, something that is very, very fun. It's a structured technique, and certainly for us in MBA 720, it is something of high interest. So in this recording, what I'll do is take you through the technique of technology forecasting. So let's jump into our presentation here and take a look at the technique itself. Again, this is something that is used by technology companies as well as manufacturing companies, marketing companies. It's a fairly standard technique. It has its origins right out of the engineering disciplines, actually, and certainly found its way into business, with the advent of the internet and e-commerce, way back when, and has sort of found its place, pretty prominent now, as technologies become more sophisticated and certainly more difficult to predict. This technique certainly sort of fills an important role. So let's take a look at technology forecasting. Here's the technique itself. It's not very, very difficult. Again, what I want you to focus on and think about is the intersection between technology and what technologists do and what you as a business person does. So let's start at the far left in the blue box there, and you can sort of see trends and reference sciences. This is an important beginning in terms of the wheel of technology forecasting. And it is a wheel. This goes on and spins, again and again, and reveals different things that are interesting to business people and to technologists. But on the trend side there in the blue box, what you're looking at are the reference sciences. The big sciences out there, and what you're looking for isn't necessarily technologies themselves. You're looking for the trends that the technologies embody or that they represent. So again, from a business person standpoint, I'm not so much interested in Bitcoin or biotechnology or gene editing as a technology itself. I'm really interested in the trends that it represents, because those trends will have big implications, for different business models, different things out there. So again, that's what we're looking for. So you can see in the reference sciences, we have the information, the life, the materials, chemical, computer, engineering, and behavioral. Those are the large classes of reference sciences out there. Again, you don't have to understand the specifics of any particular science. Even myself, I'm certainly more versed in the computer and information sciences than I am in life and behavioral, and probably have some good understanding of engineering. But certainly, I don't think there's one person, maybe there is, but I haven't met them yet, that is really, really schooled or completely versed in all of them. So again, don't feel hesitant about looking into these sciences. What you're looking for are trends, and we'll talk about that in just a moment. The second part of the wheel right there at 12 o'clock is manifest first form technologies. These are the first physical manifestations of a technology. Now here's an important point, something that you really must remember. The first form is rarely the final form. So when you're looking at the first form of a technology out there, you're probably not looking at the finish line. You're not looking at what that technology will ultimately become. And that really throws a lot of people off. And I think that certainly if you kind of get yourself schooled in this technique and thinking about it in the right way, you see a first technology out there, our first form, and even if it's clumsy, even if it's awkward, if it's not exactly the polished, you say, wait a minute, that's the first form. We will see other forms down the line, or we'll see different cycles, or sometimes you'll hear it called generations that follow the first form that might be even more spectacular. But if you can identify that first form, that first physical manifestation where something jumps out of the reference sciences and becomes a tangible physical technology, and you recognize that it's the first form, and you recognize that greater things are to come, it's a pretty powerful thing. And I think that to me is one of the key skills that you want to pick up out of technology forecasting, is the ability to recognize that sometimes the first form may be an ugly duckling. It's not the beautiful swan that might be out there. Certainly that was true for even World Wide Web, internet, I would say smartphones, a lot of different things. You saw the first forms weren't very pretty. Certainly in digital music, the first music players were anything but pretty. They were anything but, polished, but it represented something that as it cycled and as it improved was going to become something big. Now, what happens after that is we look for the business model that sort of marries to or complements that first form. Will that result in a new business model? This is where you get into product, services, processes, value. For those of you interested in new product development, excuse me, this is the key part of the technology forecasting wheel, how those first form technologies result in a brand new business model. Now, that new business model might go back and inform the first technology. You see the double-headed arrows here, or the new business model informs reference sciences, and the reference sciences produce another technology that takes the physical form. So what I want you to see here is that this is a wheel of technology forecasting. It goes on and on. Now, eventually what will happen as the wheel spins is we may get a final form or a later generation technology that is then what we call completely revealed. A revealed technology, that means it is in its final form or final stages, and the business model is complete and it's tested, and so that becomes sort of final form or the final manifestation of the technology. Then we look for other things, that might spin out of the wheel. So this is the essential three parts of it. It is a lot of fun. It is one of your projects. So what you could do is go in, take a look at trends in reference sciences, identify those first forms, and then talk about different business models. This would really, really be sort of the heart and soul of why you take a class like this, where you're sort of combining technology with new business models out there. And again, you don't have to be steeped in knowledge on any particular technology or any reference science to play the game. You really don't. In fact, I think that some people that maybe are a little less, technically involved, in a reference science or in technologies might be a little bit better at this, because, you really have to kind of come out of the weeds to identify those new business models. So that is the wheel of technology forecasting. Let's go in and take a quick look at each piece of it. So here are the reference sciences. This is the science that underlies the innovation. Now, there are many ways to identify these trends. Of course, ChatGPT, Gemini, Copilot, you can certainly use AI these days to kind of uncover trends. In fact, it does a pretty good job of it. I also read non-business types of publications, Scientific American. I know that sounds nerdy, but it's actually quite good, and it really uncovers a lot of interesting, things in science and reference sciences that sort of are on the way. The MIT Technology Review is also another good source. Both of them are online. Both of them are searchable, and don't be surprised if you use a AI technology that it doesn't go straight to Scientific American or MIT Technology Review for the source information. So I read these things. I can't tell you that I understand everything. If there's something in astrophysics or an article around that, I might not understand every specific of what's going on, but what these journals do is they really kind of give you a great overview of what that technology might be. So that is a reference science. Let's just jump into each one here very briefly. There are the information sciences. Again, This is a field that certainly I would classify myself as fairly strong in, and that's analysis, collection, classification of information. And I think that what I would do is expand that a little bit, and how that information becomes knowledge, and how that knowledge then impacts decision making, or how it impacts markets, or how it impacts customers. So what information sciences really does is focus on data, information, and knowledge, how it is gathered, how it is stored, how it is distributed. I like to think of it as a study of a river, out in nature. You're looking at that flow of information, that flow of knowledge, where it comes from and where it goes, who uses it, and how that is changing. This is a very rich source of good trends in terms of new technologies and technology forecasting. So the information sciences. Second is the life sciences. This is the interesting one, and I think one of the more dynamic ones these days. It's also probably the science that I am not strongest in. I would love to be stronger in life sciences, but it just wasn't my path in terms of study and in terms of sort of how I migrated through my studies. But it's really interesting. I can still understand it. What life sciences is the study of living material, so organic material, microorganisms, plants, human beings. I think that it's kind of a evolving area, a somewhat controversial area from time to time, because computational science is now sort of invading or starting to sort of melt in with life sciences and giving us technologies that are really remarkable on one hand, but also fairly controversial on the other, namely gene editing, DNA editing, things like that. But basically this is living material, and so kind of interesting that this is a big industry now, and the life sciences industries are really hoping to find more business students as they go forward and develop their business models, as they start to think about new ways to make money, the ethics around that, putting up guardrails, things like that. So the life sciences, where at one time would have been not as compatible a place for business students, is now certainly red hot. And you don't have to be a biology major or someone that's steeped in it. You really just want to understand the trends and how they're impacting business models. The material sciences are the opposite of the biological sciences. This is non-living material. So the properties of new materials, solids. The big technology here is nanotechnology, which we will talk about as one of the 7 technologies. But here what you're actually doing is looking at the re-engineering and recombination of non-living particles. So an example of this might be creating the wing of a jetliner that is light yet durable. What would happen in that instance is that the natural properties of metal might be rearranged through nanotechnology or some other process so that it creates a metal that doesn't exist in its natural form in nature, but can exist in a reinvented form as something else, stronger, lighter, different. The real, I think, interesting part of material science is certainly it's going to be battery technology, energy technology, solar arrays, things like this that will be able to store and generate energy in a completely different way than is done in the natural world. So what's really interesting about the material sciences is sort of the technologies that are combined with other technologies to create materials that don't exist in nature, but are composed of materials that exist in nature. So that's the material sciences, really interesting. Chemical sciences, again, this is my weakest. I dodged chemistry courses like you wouldn't believe. To this day, if I see the periodic table, I get nervous. But it is an incredible science. Again, this is really looking at elements and compounds atoms and molecular level. So it is very closely related to material sciences, but it is distinct. It is really sort of in between physics and biology. Interestingly enough, certainly at the University of North Carolina, we have one of the strongest chemistry departments in the world, and these academics have created a lot of different inventions and a lot of different combinations of chemicals that are world renowned and have been highly recognized. So very interesting that we have such a strong chemistry department in North Carolina. One of the areas that I manage at North Carolina is the Collaboratory, the North Carolina Collaboratory. And in the Collaboratory, what we do is take money from the state of North Carolina and invest it into projects. Anytime we can find a chemistry project, we know that we're going to get good return on that money. They always deliver. They really do well. Some of the projects that we've done in chemical sciences that are interesting is the testing of well water. One of the things that's interesting about the state of North Carolina is that a lot of the water here is pretty high in iron. So as far as the state goes, we're not blessed with incredibly robust water supply, and over time some of that water supply has been polluted by companies dumping chemicals into our rivers, into our lakes. And so North Carolina has had an issue with this, and one chemical that is very dangerous and that has sort of found its way into the water supply is called PFAS, PFAS. And we fund a lot of research that sort of tries to take that out of the water, tries to test for it. And certainly one of the good projects we invested in chemical sciences was the testing of well water, just using a cotton swab or a material where when that water is high in PFAS or high in lead, that swab or that material will tell you that, and you can have the well corrected. And anybody can do this test. And that came out of our chemistry department, funded by us in the Collaboratory. If you're interested in what we do at the Collaboratory, it's collaboratory.unc.edu, collaboratory.unc.edu, or just go to a search and just type Seegers and Collaboratory, like collaboration and laboratory, combined into one. And you can see sort of the things that we do. So interestingly enough, and the reason I tell you that long story is that I myself am not schooled in the chemical sciences as much as I would like to be, but I am in charge of research and development moving into chemical sciences. So I don't have to understand that technology completely. What I need to understand is the implication, the problem we're trying to solve, how it helps the state, and then I can move money to those chemists. They can do the project, and we get a good product out of that that helps the state of North Carolina. But I myself, the money manager, am not the most most knowledgeable person in chemical sciences. All right, let's go to the computer sciences. Oh yes, this is another home base for me. Certainly computer science is the study that really I think of this as more of devices and machines and algorithms and software is what would be part of computer science. I think one of the more interesting pieces of computer sciences these days is data visualization, and that is using computer science models, software, machines to take data and give it more of a visual type of property. So to me, and that's one of many, ambient information, a lot of different things in the computer sciences these days. So there's a lot of good, I'd say, innovation, a lot of good product development coming out of computer sciences in terms of a referent discipline. Engineering sciences certainly is the building. It integrates a lot of math, physical sciences, even with the arts. So this is how you build things. Certainly 3D printing has had a big impact on engineering sciences. Precision robotics has had a big impact on the engineering sciences. Interestingly enough, the engineering sciences sort of created robotics, and then robotics helped engineering sciences in turn. So a lot of good technologies coming out of the engineering sciences, combining with nanotechnology and other things to create worlds that we didn't know existed. So quite a good discipline. The behavioral sciences is one that you might find a little surprising in terms of adding in here. This is actually how people react to technology. It's really, really important. I'm going to say I was a late comer to the party on behavioral sciences. I did not study a lot of behavioral sciences. I avoided psychology courses as much as I could through college, but as I got into the field and I got into research and started getting into why someone would accept a technology or why someone would reject a technology, you certainly saw the behavioral aspect of it being very, very important. And interestingly enough, even in my own research, I started incorporating more and more behavioral economics, psychology, and things like that into it to sort of explain outcomes of technology. And it's interesting, particularly in the world of artificial intelligence these days, how people respond to artificial intelligence, how they use it, what they think about it. And it does explain a lot of what you see and hear when you read about artificial intelligence. So it's kind of a interesting science from the standpoint of its placement in terms of technology forecasting, but I think it's one of the most important. I certainly have become a believer over the years in the behavioral sciences. So it's really important. Consumer behavior. I was surprised, quite a bit when we were developing some products at Apple, doing research around that. The response you would get from somebody, on a project, or to a technology, they would really surprise you. You felt like the answer was one way, and yet the behavioral outcomes were someplace different. And the people that were giving you these outcomes couldn't even tell you why they did it. So it was really kind of interesting, how the behavioral sciences went in there. Well, what you try to do when you're going into these reference sciences is look at trends. A trend is something that explains a lot of what you see. So it's, like if you looked at something like a hula hoop, that's a technology, that is a product, but the trend behind it is fitness and fun. To make fitness, something important, but to also make it fun. That's the way you have to look at products. It's really strange sometimes to try to detach yourself from a product itself, and start describing a product. Detach yourself from it and try to explain what the trend is. And let me jump into that and show you some. In biotechnology, one of the major trends is certainly prevention of disease rather than treatment. So if you look at gene editing, if you look at CRISPR-Cas9, and again, we will talk about these technologies, so if you don't know what they are, don't worry about it. But if you really look at the trend behind them, we're moving away from treating disease and trying to prevent it. That's the major trend. So if that is a major trend, you have to wonder, how will the business models change? What are the manifestations of technology that sort of describe that? And what I would say is that gene editing is a first manifestation of a technology that represents the trend of prevention rather than treatment. Therefore, you're going to see Genentech and other pharmaceutical companies start to build business models around that. That's where you come in. How do we monetize that? How do we make sure that technology is not exclusive to some people and unreachable by others? These are important things. again, you don't want something that is going to make society worse. You want it to make it better, and that requires some thought. Information, I talked about this in pervasive computing, but ambient information, where information finds its way into windows, into the windshield of our car. It's already happening, but that is a combination of information sciences and probably material sciences and computer sciences, where we're going to start to see information that's even projected onto molecules in the air. Interoperability and plug-and-play technology is a big trend in engineering. We're actually trying to build things that are more modular. That is a big trend in the engineering sciences. A lot of the good universities are certainly teaching that to their engineering students, and it's becoming a way that we think about devices. And in terms of as they scale and as they change and as they upgrade, interoperability across generations. Precision materials are certainly part of the material sciences there. Even what I would say precision medicines, which might be part chemical and part material, but things that are more designed in precision, more customized. Behavioral self-expression. TikTok is a technology. I would say it's probably in mid-form. It might be on its way to final form. The trend behind it is self-expression. That's the way you need to think about these things. Don't think of TikTok as someone falling off a treadmill or someone, getting a, bag of ice thrown on top of them. These funny things that we see. It's self-expression. It's self-production. It's user-based content. That's what the trend is, and it comes right out of the behavioral school. Certainly recycled chemicals, recycling, sustainability, big trend in chemical, and in computers, we talked about this, distributed processing and smart processing at the edge. So these are some that I picked out. You may pick out others. Notice the title of the visual there, some trends. There are others. I went in and picked these out. That doesn't mean that's all there are. It doesn't mean that these are the best, but I think they're interesting, and I think it gives you sort of an idea of how to think about the technologies you see. Try to see the big trend behind the technology, and typically a trend will be found in 2 or 3 technologies. You'll see the trend that unites them all. And you can link that trend typically back to a reference science. So this gives you sort of the idea of trends and reference sciences, the blue box there. Next, what you're going to do is look for physical manifestations of technologies. The first form technologies are the actual physical manifestations. Now, to prove my point, I'll show you that most of the technologies in first form are pretty ugly. That is an early form of a computer, or what they would call the counting machine. Many years ago. That's ugly. That's not what the computer became. But when that appears, it is starting to set a trend. It's starting to set a technology life cycle that may be really important and may result in different models out there. This is an actual photograph of one of the first prototypes of iPod. It was just a box, just cut up, and you can see drawn on. That's how it looked in the beginning. It did have its beginnings in terms of modeling what was called a T3 transistor radio. So the iPod, when it became in its final form with click wheel and all, was actually modeled after a transistor radio. That was a really good one. The T3 was an incredibly great transistor radio. These things, don't exist, too much anymore, but back in its day, the T3, which was way before my time, but it was something really good when it was my time, when I started thinking about design and teams think about how something will look. That was a good foundation for me. And really, what I'm showing you here is that was the T3's final manifestation, and it became the first manifestation for iPod. So technologies run through their cycles. That doesn't mean it's over for them. Sometimes years later, they can provide the first footprint or the first manifestation of a brand new technology. So again, what you see is first form technologies. You don't necessarily see the final form. And let me show you how things cycle through. And can kind of give you an idea. This is the smartphone. If you take a look at how it cycled through, you had the touch screen, the stylus, which would have been Palm Pilot way back when. Then you get into the flip phone. Then you get into what was called a Trio. That would be the fourth cycle. Fifth cycle, you're still on keyboards. Notice the difference between the fifth and the sixth. Let me just talk about this. Between the fourth and the fifth, you move away from stylus to a keyboard on the device. From fifth and sixth, you're moving to touch screen. That was a good jump. So these generations aren't equal in jumps. You get a bigger jump between one and the other sometimes. The seventh generation, that's kind of where we are. And we've been stuck on that for a long time. I'd say for the last maybe 12, 15 years. We've kind of been in that seventh cycle. Everyone's wondering what's next. Some people think that OLED technology might be the breakout there to move to a brand new cycle, a new form of smartphones that are radically different from that, original, we would call that the legacy cycle, the first, set of cycles, 1 through 7 there. And then you jump into a new cycle. I don't know that OLED is going to do that, but I'm just giving you some information from other technologists, kind of the way they're thinking about it. But that shows you the different generations. And when you become aware of this, it's really fun. You can kind of say, well, when they create a new smartphone and it has slightly better screen technology, well, that might not even be an 8th generation. That's a 7.1 generation out there. You're just making these little incremental improvements to it. What you really hope is that you can jump a generation, or even better than that is jump on a new cycle. And that's what everybody's looking for. So that's kind of the key to product development there, is jumping between cycles of an established form, or hopefully jumping off that cycle completely into a new profitable cycle. But to do that, you need a new technology, or you need a jump in technology, something revolutionary out there that allows you to make the jump. I love this. This is just absolutely fun to think about. It's a way to really kind of get underneath the hood of forecasting technology. And at last, this comes into, I think, the business piece of it. Those new technologies, those new cycles, those new generations will result in new business models. Perhaps something that has never existed before. Certainly TikTok was a manifestation of a technology that was different than YouTube, and then resulted in a new business model. I think that business model is still evolving, by the way. But in any case, this is where I think, the business thinking comes in, sort of the handoff between a technology person and a business person is the cycles and then the technology. So again, this is something that is business-like. It really marries, what technologists do with what business people do. It is a great technique. You'll get a chance to do this as a project if you want to. I heavily encourage you to consider it. It is one of those that when you do the project, you've got something that you can present to recruiters and say that you did this project and it was something unique and novel. So that's technology forecasting. I hope you enjoyed this presentation. More than that, I hope it changes the way you think about technology, and you understand more the combination of business thinking and technological thinking.